This is your lucky sir. We will discuss about water. Few questions about water. In ice, each oxygen is surrounded by 4 oxygen atoms in tetrahedral position. Right? Tetrahedral position it will be. Sorry. Then coming to H2O plus H2O gives us H3O plus and OH minus. In this reaction, water acts as one water is losing proton, so Bronsted acid. Another water is accepting proton, so Bronsted base. So overall, accepting and releasing, that means amphoteric. So 1, 2, 3, all correct. Copper sulfate pentahydrate CuSO4 5H2O, PCl3 plus H2O, H3PO3 plus HCl. In the first case, you can see copper sulfate dot 5H2O. Okay, now when dot 5H2O is there, you are adding water. Okay, so this is called hydration. In PCl3 plus H2O, chlorines are out and water molecules are in, that is in the form of OH. So this is hydrolysis. Hydrolysis means you are breaking the bonds using water. In the first case, you are just adding water, so that is hydration. Second is hydrolysis, option 2. Actually, I forgot the iPad pencil, so I am just answering without. Okay. So chemical is soap is sodium stearate. Okay, the sodium stearate. Direct question. Hot water is one which contains dissolved salts, and which does not give good lather immediately with soap. Dissolved salts, but not sodium salts, calcium and magnesium salts. So for 24th question, the best option is third option. Does not give good lather immediately with soap is hot water. Coming to hotness of water is due to the presence of, as we were discussing, calcium, magnesium, chloride, sulfates, bicarbonates. Calcium, chloride, magnesium sulfate, calcium bicarbonate. So all of these. Coming to question number 26. Temporary hotness is due to bicarbonates. So option 2, magnesium bicarbonate. Permanent hotness of water arises due to the presence of chlorides and sulfates of calcium and magnesium. Option 1, direct questions. Temporary hotness of water can be removed by boiling. Okay, now when you boil, magnesium bicarbonate is removed in the form of magnesium hydroxide, calcium bicarbonate in the form of calcium carbonate. So by boiling. In Clark's method, we add calcium hydroxide. Okay, now but remember, calcium hydroxide, if you are adding extra, that turns into artificial hotness. Okay, now so 29th question, option 3, Clark's method, you are adding temporary to remove the temporary hotness, calculated quantity of calcium hydroxide, not too much. Okay. The raw material used for preparing permutite is sodium, aluminium, silicates. Okay, now Na2, Al2, Si2OH. Sodium, aluminium, Na2, Al2, Si2OH. Sodium, aluminium, orthosilicate. So you need soda ash, alumina, silica, all of this. This is now not required for you because this is a old syllabus question, I think. The common name of sodium hexametaphosphate is calgon. Calgon means calcium gone. Remember like this, calgon when you are using calcium gone. Surendra Reddy sir, right? Calgon, calcium gone. Sodium hexametaphosphate, NaPO3 taken 6. NaPO3 taken 6. All 6. The group responsible for the removal of cations in ion exchange resin is, that is acid, COH. In ion exchange resin, COH removes cations and NH3OH removes anions. Exhausted anion. Exhausted means it's gone, it is not working. That can be revived by using a solution of. Exhausted is always revived by anion purpose. We are using base. For cation purpose, we generally use acid. Okay, now for 33rd question, you can use base means NaOH or Na2CO3. So both 1 and 2. Exhausted cation exchange resin is regenerated using solution of moderately concentrated cation. So you can use acid. So 34th question, option H2SO4. For cation exchange resin, acid, anion exchange resin, base. So we will continue up to 46. Then hydrogen peroxide will take in another video. Fine. 35th question. Degree of hotness of water is expressed in terms of calcium carbonate. 35. That is one technique of saying calcium carbonate. Hardness of water is expressed as the number of parts by weight of calcium carbonate. Just now we are discussing 35, 36 questions are same calcium carbonate. Actually, the interesting point is calcium carbonate is not responsible for any type of hardness, but it is measured in terms of calcium carbonate. In order to confuse you, they gave you the options you see CaCl2, MgCl2, CaSO4, all these cause hardness, but not CaCO3, but it is measured in terms of CaCO3, right? Bichara. So heavy water, coming to heavy water is very limited now. Okay, now we'll see what type of questions are present here. In heavy water molecule, okay, that is 7th question we are discussing. Hydrogen atoms are heavy hydrogens while oxygen atoms are lighter isotopes, like D2O, only H is replaced by D. So heavy water is H2O, in place of H2O we have D2O. Oxygen is normal but hydrogen is replaced by deuterium. D2O has maximum density at 11.6 memory, pure memory based question. Boiling point of heavy water is more than 100 degrees Celsius, so 101.42, again memory based question. Heavy water freezes at, okay, now this is also you can expect like water. Okay, now water freezing point, if it is 0 degrees Celsius, little higher, 3.8 degrees Celsius memory, but you can remember at least by seeing options you can say, right? The boiling point of D2O is greater than H2O because, okay, now same thing, boiling point, and in all these cases we are going to say the same reason. The molecular weight of D2O is greater than H2O because hydrogen bonding is common in these two cases. Second point is molecular mass. Higher the molecular mass, higher will be the boiling point. So 41st, option 4. 42nd question, the compound formed when heavy water reacts with CaC2. CaC2 on hydrolysis gives C2H2, acetylene. Heavy water C2D2. C2D2 is deuteroacetylene. Bond length is bond length is same in all these cases. Okay, now in NCERT also it is mentioned very clearly. Bond length is not disturbed by these. Okay, now HH, DD, TT bond lengths are going to be same. Heavy water means in place of H we need to take D. So H mass number should be 2. So option 2 you see, 44th question. Oxygen should be always 16, don't worry. Coming to 2 more questions. pH of heavy water at 25 degrees Celsius. Heavy water means what? Nothing but D2. So here no question. pH of heavy water. Breaking will be less. Okay, now at 25 degrees Celsius, water breaks into H plus ions and OH minus ions, and the concentration is 10 power minus 7. D2 won't dissociate that much because bond strength is more. So at 25 degrees Celsius, the dissociation of D plus and OD minus will be less than 10 power of minus 7 meter, like 10 to the power of minus 8, like that you can take. So overall KW will become 10 to the power of minus 16. So it is more than 7. Very, very important question, very interesting question. Don't confuse. 45, I repeat. Okay, now heavy water bonds are strong, so not breaking easily. So D plus or OD minus concentration is less than 10 power minus 7. Consider 10 power minus 8. So KW will become 10 power of minus 16. So the pH of water at 25 degrees Celsius, in that case I am saying, whatever the example I am saying, in that case it will become 8. That means more than 7. So definitely more than 7. Very, 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 very important question. In atomic reactor, heavy water is used as direct memory based question, moderator. About hydrogen peroxide, we will discuss in next coming up video.